Hello everyone, today we are starting with a new chapter, that is chapter number 15, probability. Now as studied earlier in the previous classes, you have studied a probability definition, that is empirical probability or experimental probability. Now what is that empirical probability? We will just recall and then pass on to the next section. Okay, so if I am considering an experiment of tossing a coin. Okay, tossing a coin, and you know that there are two outcomes for tossing a coin, which is head and tail. These are the two outcomes for tossing a coin. Now if I am saying that tossing a coin, I am just doing the process 1000 times. Okay, so I am doing the process 1000 times means I am just taking the frequency of the outcomes, that is getting a head and getting a tail, as suppose 455 and 545 respectively, that is getting a head occurrence is 455 out of 1000 times and getting a tail is 545 out of 1000 times. Now how will we find out the probability? What is the probability of getting the head? That is, what will be the empirical probability or experimental probability of getting a head? Of getting a head will be the total frequency, that is occurrence of the head in the experiment, divided by how many times you have done that, that is divided by 1000. So this is giving you 0.455 as the probability of getting a head. Okay, and empirical probability of getting a tail will be 545 divided by 1000, that is 0.545. This you have already studied in your earlier classes, and this is known as empirical probability. So when I definition becomes like, if I am taking, let E be an event for the experiment, that is event can be either getting a head or getting a tail if I am taking coin tossing. So what I will have, I will write P of E, that is the probability of getting the event E, is the number of trials the event happens or happened, divided by the total number of trials. Total number of trials. This will be the definition of empirical probability. Okay, now if I am just tossing the coin again another 1000 times, then the probability of getting head and getting tail will change, or you can say the occurrence will be getting a little bit higher or lower, that is it can change the values, but altogether the value will be nearby, approximately equal to, you can say that 0.5. It will be reaching approximately equal to 0.5 for either it is tossing head or getting a head or getting a tail. So that will give you an idea about what is a theoretical approach to probability or classical probability. Now the main difference between experimental probability and theoretical probability is that experimental probability is based on actual recordings or actual experiments, and theoretical approach or theoretical probability is based on assumptions. That is, in the earlier thing we saw that tossing a coin and repeating it again and again, we are just getting the probability of getting a head or getting a tail is nearby same, that is half chance to occur. For the full experiment you have both equal chance to occur. So the assumption in theoretical probability will be that getting a head or getting a tail will have equal probability, that is they have equal chance to occur. So we will take the probability of getting a head in a coin tossing is half or 0.5, and probability of getting a tail is also 0.5. Now let us start with another example, that is throwing a die. So when we throw a die, you have 6 possible outcomes, that is getting a 1, 2, 3, 4, 5 or 6. So you have 6 outcomes that you can get. So these are the these things are the possible outcomes. possible outcomes are 1, 2, 3, 4, 5, 6. And here the theoretical probabilities definition is P of E. If you have E as an event can be either getting a 1, a 2, 3, 4, 5 or 6. So whatever you are taking as the event, P of E, probability of getting that event, will be number of outcomes favorable to the event. Favorable to the event means how many chances you have to get that event, that is getting 1. How many chances you have out of these 6 chances, okay. And the total number of all possible outcomes of the experiment will be in the denominator, that is total possible outcomes are here 6. So that will be in the denominator. But what will be in the upper part? That will be, if you are having the experiment E as getting 1 or coming up 1 for the event, you will say that P of getting a 1 is equal to, you have chance, we will take it as it has all have equal chance to occur. Okay, they have equal chance to occur in the theoretical probability, equal chance of occurrence. And for that we will use a word which is known as equally likely events. Equally likely means if you have 6 outcomes, each one has equal chance to come up. So each one has means it has one chance, 1, 1, 1, 1, 1. That means when you have an experiment of throwing a die and getting a 1 is the event taken, then P of E will be number of outcomes favorable to the event, means you have only one outcome there, that is getting a 1 is the only outcome, that will be 1. And number of all possible outcomes is how many you have, total 6. So this is the probability of getting a 1. Now if you consider getting a 2 as the event, then also the value will not change. We are not writing 2 by 6, it is how many times you have that 2 in that experiment or the possible outcomes. So 2 is only one time, so you will have 1 divided by the total number of outcomes, which is 6. Again, getting a 3 will give you the same result, getting a 4, getting a 5 or getting a 6, everyone will give you the same thing, that is 1 by 6. So that is actually assumption based. That's why this theoretical is based on assumptions. We are not doing and getting the result. We are just assuming that each one of them have equal chance to occur. That is, they are equally likely events. Next one is, what is an elementary event? The meaning of elementary is you will have only one possible outcome for the given experiment. Only one possible outcome. That is, suppose you are taking, again tossing a coin once. You have 2 outcomes, that is H and T, head and tail. And if you are taking, let E be the event of getting a head. So what the event is, it is an elementary event because it contains only one H, because the possible outcome is actually H and T. The experiment has these 2 outcomes and you are getting only H. For this event E will be equal to only H, because the event of getting a head, you have only one thing. So you will say that E is an elementary event. Again, you can take E be or F be another event of getting a tail. Then also you will have F is equal to only one element in the set, which is T. So again, F is also an elementary event. If you consider another example, that is throwing a die, then also again it is only once. Okay, throwing, this is one example for elementary event. The other one, if you are taking throwing a die once, you will get the possible outcomes as 1, 2, 3, 4, 5, 6. Now if I am saying, suppose I will just tell you what the difference between what is an elementary and what is not an elementary. Okay, if I am taking E as an event of getting a 3, then I will get E as only 3 in the event, right? So here this E is an elementary event. Now if I am taking F as the event of getting even numbers, So for getting even numbers in this set, I will get f as, it can be 2, 4, 6. So this contains 3 elements. Okay, so if this contains more than one element, then I will say that this is not an elementary event. So now you understood the difference between what is an elementary event and what is not. If you get only one outcome in the event, then you will say that the event is an elementary event. If it is getting more than one possible outcomes in the event, then you will say that it is not an elementary event. Next point is very important, which is sum of the probabilities of all elementary events of an experiment is 1. What do you mean by that? If I am taking tossing a coin as an experiment, I will have two things or two outcomes which are H and T, head and tail. Now if I am taking E as the event of getting a head and F as an event of getting a tail, then P of E will be, again you have two outcomes in total which will be in the denominator, and P of getting a head is 1, so it is 1 by 2, that is probability of getting a head is 1 by 2. Again P of F, which is probability of getting a tail, will be 1. In total you can have 1 and total you have 2 outcomes, so it is 1 by 2 again. Okay, now what they are saying in the point is sum of the probabilities of all the elementary events. Here you have 2 elementary events for this experiment, tossing a coin. So they are saying that if we add the probabilities of both are elementary events as well. So if you are adding both the things, what you will get, probability of E is half and probability of F is half, and you will get 2 by 2, which is 1. That is probability, sum of the probabilities, you are getting it to be 1 if these are your elementary events. Okay, so for elementary events, if you take the sum of all the probabilities will give you 1. Now if I am throwing a die, I will have the possible outcomes as 1, 2, 3, 4, 5, 6. That means if I am getting or taking A as getting 1, B getting a 2, C getting a 3, D getting a 4, E getting a 5, and F getting a 6. Then what will be P of A? I will get 1 only one time, and total you have 6, so it is 1 by 6. Again P of B will be 1 by 6, P of C will be 1 by 6. Getting 2 is only once, so you will have 1 by 6. Again getting a 3 is only one time in the experiment, so you will have again all have the probability to be 1 by 6, right? That means if I take the sum of all these probabilities, all are again elementary events, you are getting only one element in each of the events, right? So P of A plus P of B plus P of C plus P of D plus P of E plus P of F will give you 1 by 6 plus 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 1 by 6. So how many you have? 6 events, 1, 2, 3, 4, 5, 6. So it is 6 by 6 or 1. So the sum of all these is giving you 1. Okay. So that is the meaning of sum of the probabilities of all the elementary events of an experiment is 1. Next is complementary event. Now what is complementary event? Now if I am taking E to be an event of getting a head and F as getting a tail, event getting a tail with the experiment of tossing a coin. Okay, experiment is taken as tossing a coin. So P of E will be the probability of the event of getting head, and P of F will be denoting the probability of getting a tail. Okay, now if I say this is E, I will say that F is same as not getting E, right? Not getting, this is same as not getting a head. That means I can say that it is not E, and this not E is denoted by E bar, and this is known as complementary event of E. Okay, not E, or the opposite of what is E. That is known as the complementary event of the event E. E bar is the notation used for complementary event. If E is an event, then E bar is the complementary event of E, and it is denoted by E bar. Now again we know that P of E plus P of F will give you half plus half 1. I am just replacing F with E bar, so I can write P of E plus P of E bar is equal to 1, or P of E bar is equal to 1 minus P of E. So this is the relation connecting the probability of the event and its complementary event. That is, if you know the probability of the event, you can find out what is the probability of its complementary event, which will be nothing but 1 minus the probability of the given event. Okay, P of E bar is equal to 1 minus P of E. Now what do you mean by an impossible event and what is a sure or certain event? First we will consider an experiment of throwing a die, and you know that the possible outcomes are 1, 2, 3, 4, 5, 6. So if I take an event to be, let E be the event of getting a 7 after throwing a die. Okay, getting a 7. So what will be your answer? What will be the probability of getting a 7? You can just see that you don't have any chance to get a 7 in this experiment. So you will get that P of E will be 0 divided by the total number of possible outcomes is 6. But getting a 7 is 0. So it is 0 by 6, which is 0. So if I get the probability of an event to be 0, I'll say that the event which I have taken is an impossible event. So an event whose probability is 0 is called an impossible event. The meaning itself says that this is not going to happen, or this is an impossible event. Okay. Next is sure event. Now again, if I am taking F to be an event of getting a number which is less than 7 for the same experiment, less than 7. So what all chances I have for getting less than 7? It can be either 1, 2, 3, 4, 5 or 6. So you have 6 chance there. So you will write what will be the probability of that event. It will be 6 out of 6. That means 1. You are getting the probability of this event of getting a number which is less than 7 is 1. So you can say that the event is a sure event. That means if an event is having its probability to be 1, then it is known as a sure event or a certain event. Okay. So in general we can say that the probability of any event will be lying in between 0 and 1. So to the minimum it can go till 0 if it is an impossible event. Remaining you can get the value as in between 0 and 1, and it can be up to the maximum of 1. That is, if it is a sure event, you will get the probability to be 1. So the probability generally lies in between 0 and 1, including 0 and 1. Okay. And this is because every time the numerator will be less than the denominator. Now if the numerator is less than denominator, or it can be less than or equal to the denominator. So it will be every time lying between 0 and 1, or if the numerator is equal to the denominator, then the value will be 1. So the probability will be for any event, probability of that event will be lying in between 0 and 1, and it can happen as 0 and 1 also. Next is a very common experiment which is very interesting, and it is related to playing cards. Have you ever seen a deck of playing cards? It contains 52 playing cards and it is divided into 4 suits. 4 suits in which you have 13 cards each. That means you have 4 shapes for each type, for each suit. Okay. In each one you have 13 cards. And the cards are First, shape of spade. I'll just show you that this is the shape of a spade. Then you have hearts. Then you have diamonds. And the last thing is clubs. So these are the 4 shapes you will find in a set of or in a deck of playing cards, and each has 13 cards. Now the 13 cards will be like this. Again, this spade is of black color, hearts red color, diamonds red color, and clubs again black color. So if you see, in total you have how many black color cards? 13 plus 13, that is 26 black cards. And red cards you have again here, red 13 plus 13, 26 red cards, 26 black cards and 26 red cards. Okay, now which are those 13 cards for each of the color? The 13 cards are ace. For each one you will have these things. Okay, ace, king, queen, jack, 10, 9, 8, 7, 6, 5, 4, 3, 2. Just see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So these are the 13 cards for each of the type, each of the suit. So spade shape will be having this much of cards. Again, hearts will be having this much of cards. Diamond will be having this much of cards, and clubs will be having this much of cards, of which these 3, that is king, queen and jack, are known as the face cards, because those cards will be having face of king, queen and jack. Now I will just show you the cards which will give you an idea about what we have discussed now. Okay, so you have in total 52 playing cards, out of which I have taken one suit, that is spade. You can just see the shape of spade in each of the cards. Just see, it is a leaf like structure, you can just see. So this is ace card, first one which we have written. Then you have king, K. So you can just see you have face there, right? Face of a king, that's why it is known as one of the face cards. Then you have queen, again a face card. Then jack, which is again a face card. So you have 3 face cards. These are the 3 face cards, king, queen and jack, and it will be for each of the suits. 4 suits you have, so 4 into 3, 12 face cards you have altogether. Okay, now just see, after that you have 10, 9, 8, 7, 6, 5, 4, 3, 2. So total how many cards you have? You just see, you have total 13 cards. So this is the suit, first suit, which is spade. Okay, 13 cards for spade, which is black in color, and it has all these cards together with the 3 face cards for this one. Now next one, it is heart. Here you can see heart. This is ace, 1. Okay, ace, this heart. Then king, queen, jack, 10, 9, 8, 7, 6, 5, 4, 3, 2. And these 3 are the face cards. Just see, 1, 2, 3. Okay, face cards. So again they are 13 and they are red in color. Now you have diamonds. For diamond again you have ace, king, queen, jack, 10, 9, 8, 7, 6, 5, 4, 3, 2. Again 13 cards, they are red in color, and these 3 are the face cards, king, queen and jack. Okay, and the last one is clubs, which is this one. Okay, and here again you have a, ace, king, queen, jack, 10, 9, 8, 6, all are there. Ace, king, queen, jack, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, total in 13, and you have king, queen and jack as the face cards. Okay, So I think that this will be clear for you to get an idea about the deck of playing cards. So you have in total 52 cards, out of which 26 are black cards, 26 are red cards. That means the spade and clubs are together forming the 26 black cards, and hearts and diamonds will combine together to form 26 red cards, and 4 suits are these 4, each have 13 cards, and these are the 13 cards, out of which king, queen and jack, for each suit you will say that they are face cards. So for each suit you have 3 cards, means 3 plus 3 plus 3 plus 3, you will have in total 12 face cards. Clear?